Hey everyone, welcome to another episode of the podcast. It would be awesome if you could do two really simple things for me. First off, hit the like button, that little thumbs up down there, as it will make a big difference to how many people YouTube will show the episode to. Secondly, if you're enjoying the content, then hit subscribe too, and ideally click the notification bell, because otherwise the algorithm still may not show you every new episode. All right, we're in some good tech chat this week, which is always popular, and I'm joined by Peter from OneUp to chat all things pedals. Let me know in the comments if you're a flat or a clip pedal rider. I'd love to know what that split is amongst the downtime audience. All right, on with the show. I hope you enjoy it.
I believe it's the thinnest mountain bike clip pedal. It weighs similar to a trail pedal like a XTR, but it's got a platform almost the same size as about a Saint or a Mallet DH.
Maybe they're a bit of a gateway clip, I don't know.
Like a cake or something where the surface is crisp, but the inside is soft. It still feels like a nice sort of premium locked in feel, but you're still getting the float. The ease of release is the same. So all those standpoints we tried to preserve. That's my only kind of really weird, kooky custom mod that I've done.
Peter Skarsgard, welcome to the Downtime Podcast. How's things with you?
Yeah, really good. Thanks for having me on, Chris.
That's an absolute pleasure. We're going to talk about pedal technology and design, and there's heaps to dig into with both the new clip pedal that you guys have got and the flat pedals that you've already got, of which they come highly recommended. I see they just scored as the most popular pedal in the Pinkbike Awards or Pinkbike Customer Survey, which is pretty incredible. But before we do that, just tell us a little bit about like who you are and what it is that you do at OneUp.
Yeah, absolutely. So I am a design engineer at OneUp. I've been here for just under 2 years. It'll be 2 years in January. And my background's in mechanical engineering. I studied at the University of British Columbia in Vancouver, just down the road. And I worked for a different mountain bike company for a couple of years before coming over to OneUp. So I've been in the bike industry. If you include kind of bike shop sales time as well, back in the day, I've been in the bike industry for about 10 years.
Fair play. So you worked in bike shops before you kind of got into the technical side of the engineering part?
I did, yeah. Over in Calgary in Alberta, I was in a bike shop called Ridley Cycle.
Yeah.
Great people over there. I was actually in the sales side of things though, so I wasn't doing any mechanic work for the most part. So my kind of engineering and hands-on background came from university and the jobs I've had through there.
Okay, fair. And there's a bit of a story about how you ended up working kind of in the engineering part of the bike industry that randomly, I think, involves the podcast in a small way.
Yes, that's true. So yeah, when I was in my second year, I kind of always knew that I wanted to go into the bike industry, but I didn't have too much of a clear path forward. I was emailing companies throughout my second year, trying to get an internship or placement, that kind of thing. But at the time, I think it was in about February, and I was coming up on a work term in May. I think you did a podcast with Ben Arnott, who's now one of my good friends, funnily enough, but I had never met him at the time. He was working as an engineer at Chromag, another company up in Whistler, locally to us. And I was really fascinated by his story and how he got himself into the industry and his journey. And I actually sent him a message after listening to that podcast, and he gave me a few tips, and I think he actually plugged my name to Ian at Chromag as well, who I'd already emailed a few months before that. And so I contacted Ian again, and we set up an interview, and luckily Ian, shout out to him, he took a bit of a gamble on me, and I think it paid off for both parties, I hope. But it really got my foot in the door in the bike industry. So if it weren't for that podcast, I may not have had that foot in. So yeah, I do have you to thank in part for where I am, for sure.
That's amazing. Yeah. That's cool to hear, dude. So yeah, obviously we're here to talk about pedal design, and we should start with the clip pedal, because that's a brand new product to OneUp. Yeah. And I guess the first question with something like that is why? Firstly, I suppose a clip pedal. What made that important? And secondly, like where do you start with a project like that?
For sure, I think those two questions kind of come hand in hand. Like we knew we wanted to add a clip pedal to our lineup, but we didn't necessarily have a clear goal for what we wanted it to be right off the bat. So when that project kicked off, we did a few brainstorming sessions where we're kind of trying to think through what is missing in the industry, or what is something that the rest of the industry isn't doing that we might be able to capitalize on. And what we identified at that time was there's not a lot of really thin clit pedals. And so from there, we sort of thought that if we make this pedal really thin, top to bottom, we might be able to add platform and make it a larger overall sort of footprint for the user to step on without making it the weight of like a downhill pedal, a traditional downhill pedal. So that's kind of the angle that we targeted. We tried to go with really thin and light for its class. Like it weighs similar to like a trail pedal, like a XTR, but it's got a platform almost the same size as about a Saint or a Mallet DH. That's kind of the niche we tried to carve out there.
Okay, interesting. So yeah, quite a challenge from the offset, I guess, because weight and size generally are kind of playing against each other. But
yeah, for sure.
Yeah, I understand the way you're trying to approach it. So you've got that goal. Where do you go from there? Are you benchmarking and riding and testing and taking apart the existing stuff that's out there on the market? Are you setting yourself goals? Are you kind of looking at ways to go away and solve this problem? Talk us a little bit through those early phases of the design element of the project.
Yeah, absolutely. We focused heavily on XT, XTR, Saint, like the Shimano SPD system as a benchmark, because we know that's kind of the most popular system. It's the system that a lot of other brands kind of adopts. And as we ended up doing as well, we've got some kind of key areas that we've tried to improve on that binding system, which I'm sure we'll talk about in a little bit. But yeah, mostly we focused on Shimano from the clit pedal performance side of things. In terms of the axle system, it's a little less dependent on being a clit pedal. So we examined a lot of different axle systems, and that kind of goes hand in hand with our flat pedal development as well. So nothing specific to the clit pedal, but on that subject of making the pedal thin overall, there was definitely some development that went into trying to keep that a low footprint. And so, yeah, I think they kind of work separately. They're not completely independent, obviously, but they don't need to be completely specific to this pedal. So yeah, there's a little bit of freedom we have there between those two aspects.
Yeah. So is the kind of the axle and bearing system, I'm guessing, to try and make something thin, like that's the biggest unlock, I suppose? Yeah,
like the bearing, we use a really big inboard bearing on our flat pedal currently, on our aluminum pedal. And we wanted to go towards a more traditional system with an end cap that comes in from the far end. And so we prototyped a few different options. We actually ended up developing a custom bearing for this pedal, and we're using 3 of them per side. So we get the same load capacity that you get from one big bearing by stacking the 3 side by side. And we've packed some oversized balls into those bearings so that they retain a higher load rating than the standard bearing of that size. So that was one way that we sort of kept the pedal thin but achieved the strength that we were looking for. And it did take some iteration to get there, for sure.
Yeah, and I guess that the bearings, the custom bearings, are something that you don't manufacture yourselves, right? You work with a bearing company to get those, and that sort of stuff comes at a cost as well, I suppose.
That's right. Yeah. So we worked with a bearing specific factory to develop those.
Yeah. And though once you've got that design though, and you kind of believe in the robustness, does that give you your thickness minimum, I guess, for the pedal? That takes you down as narrow as you're going to get?
Yeah, essentially. Like the outer diameter of the bearing as well as the outer diameter of the bushing are the main kind of deciding factors. And the diameter of the seal on the inboard side as well was a bit of a challenge for us, because we're trying to keep a certain thickness of the axle coming out of the crank arm to retain strength. And so we have to kind of play around with, we actually ended up shifting all of our, if you look at the pedal from the top down, and I do have a sample here. I know some of your listeners can't see this, but we've moved everything away front and back from the path of the axle if you look at it from the top down. So we've kind of put all the binding components beside pedal beside the axle instead of over top of it. And that's how we were able to kind of achieve some of that thinness, keeping the this, like the seal bore is actually the thickest part of the pedal, and it steps down from there. So we didn't really see any other companies doing that at the time. And so we kind of capitalized on that. Like it's almost the same sort of footprint with that inner bearing bulge that we have on our flat pedals, except it's much, much less apparent, and you don't notice it when you're riding. It's far enough inboard and it's small enough that it's out of the way of your chute, but it did allow us to make the rest of that pedal thinner than everywhere else.
Interesting. And you say you chose the Shimano cleat system, like, and rightly so. I think, like you say, it's the most popular one out there. And again, that Pinkbike kind of reader, viewer survey, whatever you call it, shows that. What are the advantages of that cleat system, do you think? What's made it so popular, and why were you so keen to go with it?
Definitely. Yeah. I think one is adjustability. Like you look at a Crank Brothers system, for example, you don't have that power to adjust your release tension. I think that's something that a lot of people really like about it. We also like just being able to utilize a universal-ish standard. So you can go to any shop in the world and they're going to have SPD cleats, and it's also what you're probably already going to have on your shoes if you're a clip pedal rider, statistically speaking. So we didn't want to kind of bring in a new standard that would require a new set of cleats, and maybe replacing cleats on multiple pairs of shoes. And we just think that system performs well. We really like the sort of distinct click in, click out feel. We like the float behavior. But like I said, there were a few things that we wanted to improve. So we kind of took that, and we still made a fully custom binding. And it's our own cleat as well. We opened a mold for our cleat, but it is SPD compatible. So you can buy Shimano cleats from the store, and they would still work with this pedal.
Excellent. But would they, talk us through a little bit then what you set out to achieve differently, why you went to the extent of creating your own kind of binding parts and cleat, and not going the like full SPD, like off the shelf route.
Yeah, for sure. One of them was durability, and especially of the surface finish. A Shimano, as far as I know, most Shimano SPD cleat or binding systems are like a plated chromoly steel. And so once that plating kind of flakes off, the binding's going to start to rust and tarnish. We opted to use a stainless steel binding. So those should be a little more durable in the long run through the winters and that kind of thing. We also, performance-wise, wanted to shoot for a tighter fit between the cleat and the binding. So with a Shimano pedal, you often feel a little bit of play, kind of up or down or side to side, left and right, on top of course, the float that you're supposed to feel, which is important for keeping your knees from being over constrained and that sort of thing. But we kind of wanted to eliminate all of the play out of that system other than that float that we wanted. So we really tightened the tolerances between the cleat and the binding. So when you ride these pedals, you should feel zero play when you're pulling up on the pedals. And I think that's something that like a road background rider would appreciate. It feels a little more like a road pedal in the way that you're really securely connected. And for power transfer, for those sorts of performance athletes, I think it's a bit of a benefit. And I don't think that's a negative for anyone who doesn't care about those things. It still feels like a nice sort of premium locked in feel, but you're still getting the float. The ease of release is the same. So all those standpoints we tried to preserve.
Yeah, I was going to say it felt, we'll talk a bit later, I guess, about my experience riding with them, but it did feel much more like an SPDR, like the Shimano road version when you were in, like that, like quality, consistent, obvious, like I am locked into these things, but not in a bad way, like in a I know where I'm at way. So if you picked up a pair of shoes with a Shimano cleat on and not a OneUp cleat, would you feel a difference? Obviously they'll still work, but would you feel some of that that play come back, or is it in the design of the binding itself?
Yeah, you're right. So it's in the design of the binding on the pedal. The cleats, as far as we've tested, feel the same between a OneUp or a Shimano. I haven't tested any other third-party Shimano SPD-based cleats, so can only confirm with those two. But yeah, the improvements we made were in the binding and the pedal.
Okay. So why go to the extent of creating a OneUp cleat in that case? Are there things you have done with that, or is it just because you wanted like a OneUp branded piece? Or
Yeah, we wanted to offer the cleats with the pedals, and we've also been able to offer a bit of a price reduction from a Shimano cleat as well. So customers, those cleats will sell separately, and a customer could pick those up. At least I should say in the Canadian, US markets. I can't confirm on EU, rest of the world, that sort of thing. But yeah, we've been able to cost them down a little bit. So a cheaper alternative to an SPD cleat that will work the same.
That in itself is pretty impressive, right? Shimano must be manufacturing cleats in crazy volume. You'd think they'd be able to do it cheapest, right?
Yeah, I don't know. Can't comment on the margins. It's not really my area of expertise either. But yeah, we were excited to be able to do that as well.
Fair play. So you've got your binding system. You've kind of engineered that and got loads of nice details into making that as good as it can be. How do you then decide what the kind of the shape and the platform of the pedal should look like? Because I think that with these platform style clipped pedals, I feel like that's one of the biggest challenges. Is it's easy to look at them and go, oh great, they're a clip pedal with a platform, but some don't really seem to work. Like the platform either makes the clip hard to use, or if you're not clipped in, the platform doesn't really work. Like it's hard, I think, to get that balance and make the whole thing function together.
Yeah, I think you're right. And I do think a big proportion of the support you get from a clip pedal comes from that side-to-side support. So on either side of the cleat, a little more so maybe even than front to back. So we tried to make a really wide support platform. And I believe our pedal is wider, like from, if you measure it kind of along the axle to the far outer end, than a Saint, than a Mallet DH, than most of those downhill pedals. We've managed to keep it thin enough that you don't really have the negative effect of that extra width. You're not having as many issues with pedal strikes, and it's not as in the way. So that's kind of how we tried to kind of ride that line a little bit. In terms of front to back, I do think pins are important on a clip pedal. They're not for everyone, and that's why they're removable, of course. But I like the way that it feels like there's a little bit of resistance to the float when you're clipped in. It feels a little more like a flat pedal in that sense. Like you can still adjust your feet, but you're not just kind of skating. And we tried to eliminate that with some of that reduced play that I was talking about earlier. But I think this adds to that as well. And if they're in the right position, which we think we've placed them and made them the right height and that sort of thing for the vast majority of shoes, that they shouldn't affect your clip in or clip out. But people like to play around with that kind of thing. So we want to give you options, and you can remove them if you don't like them on an XC bike or a different type of shoe. Potentially, you might not want them. But yeah, I think platform size, it really comes down to the width on either side of the cleat.
Yeah, I've found in the past where I've tried to get SPD clipped shoes set up, that it's been quite hard to get like the height of the cleat within the shoe, the pin height and all that kind of thing to a level where it actually all works. Whereas with these OneUp pedals, I literally just I threw the cleats on the bottom of a pair of shoes and went and rode, and they felt bang on straight away. Is that luck or is that judgment? Have you guys done something to ensure that happens more often than not?
Yeah, we tested and we measured a lot of shoes, and we actually ended up kind of determining a few that are generally a little worse than others, and the vast majority we work really well with, and most people should be able to run them with pins without the cleat spacer. We do include a cleat spacer, I should mention, as well, and that'll help just with those specific cases where there's something with that shoe that's interfering, or some shoes have a really deep cleat channel along the bottom, which is kind of what you were alluding to there. But yeah, we've tried to make it so that the binding's out of the way. It should fit with the vast majority, ideally with no cleat spacer required.
Yeah, it was, for me anyway, I put them on a set of Fox Union shoes, and it was like super simple. No spacer, straight in, and away it went.
Perfect. Yeah, good to hear.
Nice and easy. So with something like a pedal then, and with the experience that you've got at OneUp, like how much can you trust the virtual modeling side of things, like with, I don't know, finite element analysis and all this kind of modern computational stuff, like how ready is the pedal when it comes out of the 3D design phase, and how much is left to do once you've got actual hardware that you can go and physically test?
Yeah, for sure. In the case of this pedal, most of our finite element, or FEA, revolves around the axle system. So I did a lot of simulations on the axle, kind of isolated from the rest of the pedal. And you can get a pretty good idea. You don't necessarily get an idea for kind of the interplay between fatigue and impact strength and that sort of thing. And you don't have a really good control over kind of the hardness characteristics and the heat treatment of that axle. So you don't get the greatest representation, but you can kind of see weak areas geometrically, and you can kind of reinforce those areas. You can make sure that all your fillets and bearing shoulders, that kind of thing, are all correctly modeled in a way that they're not creating a major stress concentration. But at the end of the day, we really rely on our test riders as well as our internal and third-party lab bench testing, you can say. So we test all these pedals to above ISO standard, well above ISO standards, actually. We have a lot of test riders that are putting miles on them. So we try and get kind of the whole picture. We actually had a rider, our warehouse manager, Corey, was training for the Sun Peaks Enduro a couple of months ago, and he crashed and bent one of the axles of the pedal. And that was a really hard impact, and one that we can't really simulate that in FEA. It's one of those things that it's like a major impact. It happened really quickly, and it dented the pedal body and it bent the axle. It also bent his crank and stripped the threads of his crank. So we were pretty happy with that failure mode with it. Like it didn't injure him. It didn't fail catastrophically. It really took the impact in the best possible way. So when really bad things like that happen, really heavy crashes, we want to see that the pedal is not going to fail catastrophically in a way that injures the rider. And that's just one of those things that we need rider testing to understand that.
Yeah. You talk about failure modes, and so, I mean, my background's the automotive industry, and there's a lot of time and effort that goes into failure mode and effect analysis, which is a lot of people probably find quite dull. But effectively, it's trying to make sure that if things do fail, they fail in a way that's not going to injure people, is safe for the customer. Ideally, the product retains as much function as possible. There's all this kind of stuff. Is that something that's happening in the bike industry as well? It sounds like you're considering like what might go wrong and how can we make sure no one's getting hurt here?
Yeah, absolutely. And it's one thing that a lot of people see as a sort of shortcoming of the ISO standards, that they don't often test for that kind of end of life. So one of the other tests that we do sort of applies a proof load to the fatigue and impact and all that stuff to ensure that the strength of the axle is withheld, like it can support a rider's weight kind of thing. It's not like a use case load where it's like the load seen in heavy mountain biking at that point, because it's the end of the life. There's already been a crash. We've already like impact tested it or whatever. We just want to see that it holds enough kind of residual strength that it's not going to snap catastrophically and injure that rider on their ride out from their crash sort of thing.
Yeah, so if you have had a biggie and like bent a pedal or a crank or whatever, you should in theory be able to gently pedal out and get back to the car or the start of the ride or whatever without issues, that sort of thing. Yeah, fair. And I guess a lot of this is on the axle, right? The axle's doing quite a lot. It's enabling the pedal to spin. It's providing the bearing something to work on, but it's also holding the pedal on the bike and then holding the rider's weight and all the impact. So absolutely. I'm guessing there's a lot of testing that goes into that, and you're trying to make it as thin and as light and as small as possible, and we want it as tough and as strong as possible as well. So it's that balance of all those things must be hard to find.
Yeah, exactly. And you look at our composite pedal, for example, where the pedal body, relatively speaking, is providing very little structure. to that system that's actually holding you up. So yeah, we have to make the axle strong enough that in theory you could stand on it on its own, and it would withhold the same strength as it does in the pedal.
Yeah, fair. So were there issues then that came up during the testing and the development process with the clip pedal? Were there certain things that went wrong that you had to work out solutions for?
Yeah, there were definitely a couple things that were harder than anticipated, or that we weren't expecting to be as major of a design problem as they were. One of them was spring tension. So we played around a lot with different spring dimensions, numbers of coils, the way that the tangs or the spring ends were held by the nut that tensions, like the nut that you screw to tighten and loosen the tension. All those sorts of things played such a bigger role than we expected. We kind of just drew up a spring and we used it and it worked. Like we were able to ride our first samples and clip in and clip out, like just our first kind of one-offs from our prototyping vendor, which was super exciting. But we were like, okay, there are so many things here that we need to work on. And so that was quite a development process, as well as with respect to the axle, the heat treatment, the hardness of the axle was an interesting one as well. Like we made this axle a little bit thinner than a couple of our existing ones, like our composite pedal, for example, which is based off a very similar bearing and bushing constraint layout, but it's quite a bit thicker because that pedal body, we weren't as worried about that thin aspect. So because of that geometry, we rely a little more on the heat treatment being dialed. So playing around with surface versus core hardening. So you could think of it like a cake or something where the surface is crisp, but the inside is soft. We're trying to kind of ride that line where we balance fatigue strength with impact, and also not wanting the pedal to fracture or snap catastrophically in an impact load. So like I was talking about earlier with Corey's crash, that's the behavior we want to see. We want to see the axle absorb the impact rather than crack and break suddenly. So that was a bit of a process. Yeah,
you're really playing around with the material properties at a pretty microscopic level then when you get into that detail, because what's the thickness of the axle wall? Like it can't be very much, and you're varying the material properties through that with the way you're heat treating it, right?
Yeah, exactly. Yeah. The heat treatment it's a hugely important process in the axle strength for sure.
And then you've got to be able to make, thousands or tens of thousands of these things, and they all need to be close to being the same as well. So I'm guessing that like the quality control on that heat treatment process must be, it needs to be very tight, I would assume.
For sure. Yeah. And the batch that goes into the oven for heat treatment is a consideration too. Like ones that are around the edge might heat treat differently from the ones in the center, for example. So we really have to have pretty strict quality control on there to make sure we're getting what we want.
Interesting. And again, is that something that you guys, do you have all that expertise internally? Do you work with like a heat treating supplier that helps you develop all this stuff?
Generally, the heat treatment supplier is a second tier vendor. So they work with our vendor that is kind of assembling, and the ones that we're ordering these pedals from. Yeah. That vendor will work with the heat treatment vendor. Uh-huh. So we get kind of a bit of a game of telephone, but that's one of the reasons why we think it's really important to physically travel to Taiwan and understand these processes better. The last time we were there in March, we visited our heat treatment vendor, and they can, through translation, obviously with our vendor contact, we can really understand how it's working, see that process kind of happening, see how they're racked and loaded into the ovens. And so stuff like that really helps us to gain our own expertise, and we can then take that information and specify exactly what we're looking for, and our vendor can work with heat treatment vendor to achieve those properties.
Yeah. Have you had the opportunity to travel to Taiwan a fair bit then as your time in the industry? Yeah,
I've been 3 times now, all with OneUp. And each of those times, this this clip pedal was a major reason for that trip for sure. Yeah, different stages of between like early sort of meetings about our development to like initiating production. And I was there most recently a couple months ago, kind of examining those first few to come off the assembly line and making sure they were as specified. So yeah, trips like that can save us a ton of time and effort and money, and just they really help you to build the relationship with the vendor and communicate in a much more effective way what you're after than over email or like a Skype call, that sort of thing.
100%. And amazing to see like the level of skill and capabilities in these places. I think people certainly in the past were kind of guilty of assuming that like a lot of simple manufacture maybe was done in you know, in the eastern part of the world, but actually there's an incredible amount of skill and people that really know what they're doing with these very complicated processes out there.
Yeah, absolutely. And they become so specialized oftentimes in, for example, like in this case, like our factory is making almost entirely pedals. And so they're really experts in that field. They know exactly on their own end what they need to be looking for a pedal to work. And they sometimes give us advice, although we really try to push our own designs. We are confident in our engineering as well, but their side is really helpful in helping us with that product development as well. And there's so much that's boomed in the last maybe decade or even 5 years or so, like since COVID, like in terms of robotics and automation, and they're really, really dialed over there. Like it's really impressive. Every time I go, I'm blown away.
That's very cool, eh? And another thing that I was impressed by was actually the packaging that the pedals came in, which is maybe not what most people look at, but I'm a bit of a geek for that kind of stuff. And they were really nicely packaged, and it was, I'm pretty sure, all cardboard or recyclable. Like I don't remember there being anything in there that wasn't. Do you get involved in that? Is it someone else? Is it like a different supplier? Is it internal? And how much work goes into that? Because it's one of these things that people never really think about, but is often not straightforward.
Yeah, for sure. Yeah, and thank you for the opportunity to shout out Claire, who's our graphic designer in-house. She works right across the room from me, so we have a lot of involvement together with it, but it's all credit to her. Like that's a fully custom box. Yeah, you're right. It uses entirely cardboard. It's fully recyclable. Pedals are really well retained in there, and it sort of displays I have one here, sort of displays the pedal front and center there. And yeah, she's done a fantastic job with these. And yeah, like it's definitely a part of the user experience. When you pick them up in a shop, you want to see that it's kind of well put together, and you don't necessarily want to have to open a box and take apart a couple things to kind of see what you're after. So yeah, great job from Claire for sure. Yeah,
good work, Claire. And there's the cleats, obviously, and the cleat spaces in there, and then there's a little tool as well, right? Talk us through that.
That's right. Yeah. So it's a really simple little socket, and it's used to take the bearing nut off of the bearing. So that's the nut that sort of holds a lot of the axle system together. And you could, in theory, use a standard, I think it's an 8mm hex across socket with that. But because of that thinner footprint, most standard sockets that you get out of a set aren't going to fit into the end of the pedal. So we designed a little custom thinner one, and we include that with every pedal just because we want you to be able to take it apart, grease your bearing axle system, and put it back together without having to order any special tools.
That's awesome. So yeah, full like rebuilds and servicing and stuff are all easily doable at home, right?
For sure. Yeah. It's all quite simple. There's no rocket science going on in that axle system. It's quite straightforward. Yeah.
Yeah. Is that a big part of the consideration in the design for you guys as well, that sort of robustness and longevity of the products?
Yeah, absolutely. And serviceability has always been huge for us. And it's become a huge priority in all of our designs. Like, for example, the V3 dropper post that John Staples designed, you can take that whole thing apart with a multi-tool, with one of our EDC multi-tools. So that's something that we're really proud of. We want to prioritize serviceability. So yeah, it's definitely a consideration.
Nice. And what else are you kind of most excited about with this pedal then? What parts of it are you kind of smiling about every time you think about it? What were the biggest achievements from the project?
Yeah, absolutely. The how thin we were able to get it, I'm really happy with. I believe it's the thinnest mountain bike clip pedal on the market. Not sure about ever. I'm sure there's been something crazy out there, but yeah, it's really thin, and it allowed us to kind of like target XTR trail pedals in terms of weight, but we're right up there with like people actually pick up these pedals and they're like, oh, I wish the platform was a little bit bigger. Like they're really light though. And you have to be like, well, actually like hold them up next to a Saint. Like they're almost the same. You're getting the same amount of support. So I'm really proud of that. I think we've kind of found a little niche, that platform size to weight ratio.
Good effort. And they're available now, right?
Yes, they're available now. Should be available on most channels, definitely online on our website. Yeah, go and take
Excellent.
a look.
Yeah, I had a chance to ride a set for a ride last week, and I guess to qualify, I'm not generally a clips rider. Like I rode clips from about 13 to 15 years old, so I've not really ridden clips much at all for 30 years. There you go, admitting quite how old I am. I've dabbled with a few over the years, but never stuck with anything. And these, yeah, like I say, first thing, they were super easy to get set up compared to anything else I've tried in the last few years. So yeah, threw some cleats on the shoes and they seem to be basically bob on straight away, which is unusual on platform clip pedals from my experience. Yeah, the platform for me felt big enough without being kind of huge and in the way. Like I deliberately rode a few sections with one foot clipped out to just sort of test how that felt, and it felt absolutely fine. Didn't feel like I was skating around on the kind of cleat or the mechanism. Yeah, they're the first clip pedals I've ridden in about 30 years that make me think I could possibly be a clip pedal rider again, which is kind of strange. Like maybe they're a bit of a gateway clip, I don't know. But I took them off to test your flat pedals on the next ride. And I've actually put the clips back on today to go riding tomorrow because I'm kind of keen to spend a bit more time on. So yeah, as someone who's struggled with modern clips and has ridden flats for 30 years, like I think you've done a good job. They feel super easy to get in and out. And when you're in, they feel very kind of confidence inspiring. So yeah, good work, man. I think you've done a good job.
Thank you. Yeah, appreciate the kind words. Yeah, glad to hear you liked them.
Sweet. So we should talk about flat pedals. And like I said, yeah, from the Pinkbike survey, the most popular flat pedals on the market, which is pretty good. And you've also got the most popular handlebars from that survey. Like OneUp must have been pretty stoked when all those results came out.
Yeah, definitely. Yeah, and the vital surveys the last few years, people seem to love our handlebars, dropper posts, pedals. Yeah, it's great to see. Yeah,
it's amazing. Yeah, so flat pedals then, you've got two options kind of available. You've got the aluminium pedal and then the composite pedal, which you mentioned a little bit earlier. That seems to be more and more common. Quite a lot of brands now seem to have like a composite option and an aluminium option. Why are we seeing that? Like, what's the thinking behind having the two options?
Yeah, for sure. The comp pedal is a bit more of a budget option. We try and offer kind of the same grip. It's still the same convex platform, which is a bit unique to our pedals compared to most of the industry. But the flagship product, kind of the aluminum, it's more durable. It's a little nicer looking, we think. It's kind of, well, and in this case, it's quite a bit thinner as well. So we've got kind of one of the thinner flat pedals on the market, as well as, especially with that thin leading and trailing edge due to the convexity. They're quite thin and they avoid rock strikes really well. And so those are kind of the benefits you get with the more expensive product. But the comp is one of our best selling products. It's really popular as well. People really like that one too.
I can imagine. Yeah. So yeah, talk us through convex versus concave then. So what's the theory for you guys going convex? Because like you say, a lot of people in the market will go the other way.
Yeah, absolutely. It was born because we were thinking about the way that riders shift their feet further forward on the pedals when they descend, to often kind of get more of the center of their foot on the pedal. And we were looking at the way the foot kind of bends, and the ball of your foot is kind of convex, and it would accept a concave platform really well. But we actually thought in testing that the convex platform felt better for descending because it sort of cups the way your foot naturally arches. And we also found it better for allowing you to drop your heels a little bit because the trailing edge of the pedal is kind of falling away a little bit. So when you're trying to get your utmost support and control on the descent, dropping your heels is kind of the way to do it. And we found that the convex pedal did a better job of that.
Okay. Do you think there's anything to be said in like getting less fatigue? So if the kind of arch of your foot is better supported by that profile of the pedal, do you think there's maybe less fatigue from a OneUp pedal?
Yeah, absolutely. I do think so. And like, especially, it depends on the stiffness of your shoe as well. There's a lot of factors involved there for sure. But I think it's a more natural feeling to ride a convex pedal in my opinion. And I should say, like, there's always interesting things going on in the bike industry in terms of kind of trying to find innovations, and we've got some cool things coming as well with platforming as well. So something to look forward to in the flat pedal world as well.
Yeah, so there's new flat pedal technology from you guys at some point in the not too distant future then?
Yeah, some point soon. Yeah, for sure.
Excellent. So do you, like, platform size is obviously a thing, and I think you've gone fairly big, but not crazy big with yours. Like, do you think there's a relationship between ideal platform size and shoe size? And if there is, how did you choose where to put your pedal, or why not to go with like multiple sizes of pedal?
Yeah, definitely. And actually, I should mention, we do offer a small version of our composite pedal. That was released in 2023, I believe. And that one comes with a bit of a variation on pins where you can sort of cover the harsh thread of the pin. And that's more because we assumed that these would be used a little bit on kids' bikes and that sort of thing. But in general, we try and walk the line a little bit. We don't want to have such a massive platform that it's hanging out over the edge of your shoe. But we usually say, I think it's about size 8 foot and below, we sort of steer people towards the small composite pedal. Mm-hmm. But we think that the alloy pedal is a pretty good kind of happy medium in terms of size. It fits most people's feet pretty well, we think. And
that's a North American size 8, right?
Yes. Sorry. Yes, that would be. I don't quite know what that translates to.
I think it's a UK 7, EU 41, but I would have to double check somewhere around that. I think the EU size up from our, we obviously don't want to have standardized sizes anyway, do we?
Yeah.
That would just make life too easy.
And don't quote me on that 8. It's on our website on that small composite pedal page. So you could take a look if you have smaller feet and you're interested in something that might fit your feet a little bit better.
Nice. What is the kind of, what's the same then, and what's the different between the two different pedals and the two different material choices?
Yeah, it's a big part of it is the axle system. We chose a simpler axle system on the comp pedal to save cost. We tried to keep that a really price point oriented pedal, and that's part of the reason we sell so many of them. I think they're $49.99 US. Again, don't quote me on that, not the numbers guy, but they place really well and in that market. And I think if we were to go with an axle system more similar to our alloy pedal with that bigger bearing, that thin layout, I think the Kona Wawa pedal is kind of along those lines. Mm-hmm. And we don't quite see the same price point advantage there as we do with the comp pedal. So it's just really simple. It's a workhorse. It gets the job done. We really tried to keep the price down on that one.
Yeah, good effort. Is that the only differentiator in the price? Is there a difference in like the processes involved in making it, or material costs, or any of that kind of stuff?
Yeah, absolutely. And then the composite pedal body itself is made with an injection mold, and it's after the initial mold fee is incurred, the unit cost on those is quite low because it's just a shot into a tool, comes out, it's pretty much ready to go. There's really not much post processing required other than trimming a bit of the flash and deburring and that sort of thing. Whereas The alloy pedal is forged, so it's essentially stamped with a big tool under a lot of heat into a rough shape of the pedal, and then there's a whole CNC machining process afterwards to machine the bore of the axle and take away some of the flash from the outside of the forge and all these other things. So it's a much more labor intensive process. It goes to anodizing after that. It gets laser etched, whereas the logos are all just debossed into the plastic of the comp pedal. So it's all kind of one step and it's done. So that saves a lot of cost.
Yeah, and forging tools are quite expensive from what I remember, right?
Definitely, yeah. And injection tools are as well. It's mostly in that post-processing that you really incur the extra cost with an alloy and the material cost itself.
Yeah, a lot more steps to go through, I guess, to get it from raw material to a finished product.
Yeah, absolutely.
Yeah. And so is the biggest difference between the two of them then, would you say, kind of like durability and robustness? And I don't know if I'm phrasing that right, but like I would assume it's a bit easier to break a composite one.
Yeah, in the field, in terms of like what you'd actually feel on the bike, the grip and that sort of thing is quite similar. It's mostly in the durability. Like if you take a really hard impact on a comp pedal, it'll probably snap, whereas the alloy pedal is going to deal with that better.
Yeah, I mean, like I say, I rode the pedals last week. I put a composite pedal on one crank and the aluminium pedal on the other. And I think if I was blindfolded, I'd have struggled to tell you which one was which.
Mm-hmm.
Like,
the pins are different. Like we do a threaded pin on the composite pedal and a hex pin on the aluminum pedal. And the threaded all the way up pin saves a bit of cost, but some people actually prefer those pins, and you can get those pin kits for both of our pedals. So you can even use the comp pedal pins on the alloy pedal and vice versa. And they really do feel quite similar. One thing in favor of the comp pedal that some people like is if you smash a rock a little bit, not enough to damage the pedal, but just scuff off the surface, the comp pedal's material is the same all the way through, whereas the aluminum is anodized. And so once you wear off that anodizing, you're getting the kind of base metal color. So some people really love that, like the comp pedal looks the same even after you've struck it on $100. Yeah, exactly.
What's the most popular seller? I'm guessing it's the composite pedal.
Yeah, we do major volume in the composite pedal just because it's that really the really aggressive price point. Yeah.
To be fair, it's the first composite pedal that I've ridden. Like they weren't really a thing until relatively recently, I guess, and now quite a lot of brands will do a composite pedal and a metal pedal. And so I'd always been a bit snobby about it and sort of looked down on them, but they were genuinely really impressive. Like I say, it was very hard to feel the difference between the two.
Yeah, they ride really well for like an advanced rider, but then they can still be kind of that pedal where if you're at a bike shop and you don't really know what you're looking at, you just need a pair of pedals for your new bike. Like that's kind of the default. So we see them across such a range of different styles of bikes and riders. It's quite cool. Yeah,
that is good. Is there ways you would recommend people decide between the two? Is it mainly just come down to cost, or?
I think it mostly comes down to cost. Yeah, like you're getting a more premium product with the aluminum pedal, but more durable as well. But yeah, like the comp is such a workhorse. It's a great pedal too, so you can't really go wrong. Yeah.
Fair. And do you personally ride flats and clips, or do you lean one way or the other, or?
These days I ride almost entirely clips.
Okay.
And that was before I was developing a clip pedal too. It's just where I'm most comfortable. And I do ride a lot of bike park. I love jumps, like all sorts of styles of riding. I'm not much of a dirt jumper, and I would ride flats on a dirt jumper for sure.
Yeah.
But yeah, all my bikes have clip pedals on them. I do float back to flats the odd time, just kind of to remind myself that I can still do it, and I'm not like completely reliant on the ability to kind of move the bike around with clips. But I never stick with them. I just feel much more comfortable on clips personally.
Fair. And are you a tweaker? Like, do you play about with your pedals with like pin heights or moving pins, taking pins out? Have you done anything that you feel for you personally like just helps a little bit? Because I know most engineers, and I'm very guilty myself, will continually be tweaking and playing with stuff and seeing what it does.
Yeah, for sure. I think I'm more of I find something that I'll play around with it quite a bit to start. I'll find something that works and then I'll stay with that pretty much forever. I don't play around with it too much after I've found what I like. I do have a pair of our clips on my gravel bike that I've removed the bindings from one side so I can run it as a sort of flat pedal as my pub bike if I need to.
Nice.
And like we said originally, like the really locked in feel, it feels great on a gravel bike too. So yeah, I really like that. That's my only kind of really weird, kooky custom mod that I've done. Otherwise, I'm pretty much running them the way they come out of the box.
Yeah. Does that require any modification or like cutting of pieces, or can you literally just unbolt one side?
Nope. Just let the tension all the way off, and then you can pull out the 4 Torx screws that hold the binding in place and the pin that goes through the spring, and then they just pop out.
Amazing. Would they be hard to put back together yourself without all the factory equipment? I remember taking a set of SPD pedals apart when I was a kid and regretting it. Yeah,
they're not like we've tried to make them so that they can be rebuilt. Like they don't have like some pedals we saw when we were doing kind of our market research, they actually kind of mar the head of the tension screw so that you can't get all the way off. It'll stop, and so it's really not easily disassemblable at all. So that is one thing to mention. Like you can actually unscrew that screw past the point of where it's no longer doing anything, and to the point where that tension nut's going to come off. And we wanted to make that way so that it was serviceable. But yeah, it's definitely, you kind of almost need 3 hands to get in there and like hold the spring while you put the pin through, and it's a bit finicky for sure.
But doable without like jigs and fixtures and things to hold stuff in place.
Yeah.
Yeah, cool. Nice one, man. Well, we should start wrapping up. Before we do though, obviously you hold a position within the industry that I'm sure some of our listeners would be keen to have as well. Like, do you have any advice for people that would like to work within the kind of technical side of the bike industry? Are there certain things that you would recommend people do or think about?
Yeah, for sure. I think 2 pieces of advice that I think are important. I think the first one is pick, and if you're in the position to kind of be picking, like if you're in high school, for example, and you're trying to pick what direction to go for university, I think trying to pick a degree that suits the industry is important. Like mechanical engineering degree, which is what I did, is a really strong option. I also have found that industrial design is a really big part of my job that I didn't really foresee, especially in the bike industry. A lot of these components, you focus a lot on the look and feel and style of them and tying them into your other products in the line and that sort of thing. And so that becomes a really important aspect of it, as well as the math and the engineering side of things. And it's something that I wish I was better at. I would love to be able to napkin sketch something in 3D like an industrial designer does. I think that would really be beneficial. So if you're looking to get into the industry, I think those are both good avenues. The other thing I would say, and this is actually a piece of advice that Ben gave me when I was chatting with him before I got that position at Chromag, is don't stress if you can't get that bike industry job right away. I think it's also really valuable to go get some other experience. The way it happened to work out for me, it's the bike industry is really the only engineering industry I've worked in. But for the vast majority, I think, of people, you're going to be going to a larger company, just like in Canada, that could be like a big hydro company or like an automotive or any of those sort of larger industries. You get a little more of a picture, because in the bike industry, you end up wearing a lot of hats, I think. And so the more experience you can have, I think the better.
Yeah, good advice, man. Do you think like you worked in the bike world before being an engineer in the bike world, but in the sales side of things, if you had your time again, would you want to be in the workshop, or do you think what you learned from the sales side was also valuable?
Yeah, you know what? I think that is something I've thought about before, for sure. I think I had to learn most of my hands-on technical ability from university, and then subsequently, as I got into these jobs, I just tried to absorb as much as I could from people like Ben. But I think it would have been beneficial to me to have more workshop experience than just the experience I had from working on my own bike. Definitely.
Yeah.
So that's that can totally be another piece of advice as well, is try and get some of that experience, like try and become a mechanic. Doesn't even have to be a bike related mechanic, like just getting that hands-on experience, like work on your car, do that sort of thing. That's something I wish I did more of as a kid, for sure.
Yeah, it gives you an appreciation of what's easy to take apart and put together and what isn't, and all that kind of stuff, so that when you're designing things, it's easy to design things. It's hard to design things that are easy to manufacture, easy to assemble, easy to use. I think that's the difference, right?
Yeah, absolutely.
Nice. Well, it's been super interesting chatting. Like you say, you might have tipped me with this gateway clip pedal into spending a bit more time on clips. I'm definitely going to give it a few more rides and see if I can get even more comfortable than I felt kind of straight out of the box. If people want to find out more about OneUp, where should they be looking? And do you have the retail figures for the clip pedal in your head, or?
Yes. So OneUpComponents.com, our website. We're on Instagram, all the social media as well, of course. And I believe those pedals are $159.99 in the US, $218.99 in Canada. Can't speak on the rest of the world, but they're available on all our websites.
Nice. Yeah, as this goes live, it'll be on all the websites, I guess, around the world in the relevant pricing. But yeah, thanks, Peter. It's a great pedal, and also the flat pedals, the composite and the aluminium are great too. I'm looking forward to spending more time on all of those. And yeah, I'm feeling teased by whatever it is you guys have got coming on the flat pedal side, because normally when OneUp do something, they do it a little bit differently. So I'm excited to see what that is.
Yeah, for sure. It'll be a little bit different. Absolutely. And I'm looking forward to hearing more feedback from you on the clip pedals.
Nice.
Yeah, appreciate the chat.
Thanks for your time, man.
Yeah, thanks so much.